everyone, welcome back to the channel. So in this video lecture of topological sorting, we'll be learning about the implementation of the algorithm. We've already studied what is topological sorting and its few applications. So we just want to think about how we can implement this algorithm. So let's think about it. First, let's see what will be the topological sorting for this graph. Now, we know that from the definition that the topological sorting is basically a linear ordering of the vertices of the graph in such a way that any vertex u which has an edge towards v must come before the vertex v in the ordering. That's the criteria that we must have while calculating the topological sorting, and the graph must be acyclic as well as directed. So this is a directed graph, this is an acyclic graph. So let's calculate the top sort ordering for this graph. One of the ordering can be 1, 2, 3, 5. Okay, it's basically towards 4. It's like this. Okay, 5 and 4. And 0. 1, 2, 3, 5, 4, 0. So this is one of the ordering which we can call as a topological sorting of the vertices. Now observe that we started from the vertices 1 and 2. These vertices has no incoming edge. The in degree, what do we call as in degree for 1 and 2, vertices 1 and 2 is 0. We have no incoming edge for these nodes, hence they must exist first in the ordering. Okay, that's why I'm putting 1, 2 here. Okay, because they don't have any parent, they don't have any prerequisite. We don't have to visit any other node before I can visit node number 1 and node number 2. We can just start from these nodes. Fine. Now from node number 1 I can move to node number 0 as well as to node number 3. So that we are free to choose. Let's move to node number 3. So we have already listed 1 and 2. Now we can list node number 3. Okay, because I'm coming from node number 1 which is already there. Now I can move to node number 5, so I put node number 5. I can move to node number 4, so I'm putting node number 4. And that's all. Now I will move to node number 2. From node number 2 I can move to node number 0 because this is the only node which is unvisited. Node number 4, node number 5, there node number 4 is visited. So I move to node number 0 and I list it over here. Okay. So in this fashion I'm writing the topological sorting, but how we can implement this, how we can basically store this ordering in an array using some traversal algorithm. Now observe that if we start traversing from node number 1, I can use depth first search strategy. How? Let's say I start my depth first search from node number 1. I start depth first search from here. I move to node number 3, then from 5, then to 5, then to 4, and eventually from node number 4 I have to backtrack to node number 5. Then I have to backtrack to node number 3, then I have to backtrack to node number 1, and so on. Fine. Then so just think about how we can use depth first search here. So I will start the depth first search from node number 1 and then I will move to node number 3. So let's take another. So let's see how we can use depth first search strategy to solve this problem. Okay, so let's take this graph. Let's say I start the depth first search strategy from node number 1. So I call that. So imagine this graph. We are starting the depth first search from node number 1. Why we are starting the depth first search from node number 1? Because this node has n degree as 0. It has 0 in degree. We're starting the depth first search from node number 1. Although we can start DFS from any node, we just have to pick the unvisited node first. So pick any unvisited node and just perform the DFS. So I will start the DFS from node number 1. Okay, so let's see the call stack. Okay, so I start DFS from node number 1. So node 1 will be in the call stack. Node 1 will be there in the call stack. Then I will move to node number 2. After visiting node number 1, I will perform the DFS, recursively call the DFS for node number 2. So node number 2 is in the call stack. Then I will move to node number 3. So node number 3 is visited and it comes in the call stack. Then I move to node number 4 and it is there in the call stack. I store it in the call stack, node number 4. Then from node number 4 I visit node number 6 and node number 6 comes in the call stack. The DFS call corresponding to node number 6. Now from node number 6 there is no node which I can move to. So I simply backtrack from this node. I backtrack to node number 4. So this call is removed. So when this call is removed, so when I remove this call stack, I have to store it in some data structure in the reverse order. Fine, because I want to store the nodes in this fashion. 6 must comes the last, because there are other nodes. There are 4 nodes which I have visited before I visited node number 6. So I have to put them in right to left order. So I store node number 6 in some data structure. Now I'm backtrack to node number 4. Now from node number 4 I move to node number 5 and I visit it. So node number 5 is in the call stack now. Okay, now I backtrack again to node number 4 and this node is removed. So I store this node here like this. Then from node number 4 I backtrack to node number 3. So this function call is removed. So node number 4 is stored like this. Then I move to node number 2 and this function call is removed from the call stack and I store node number 3 here. Then I move to node number 1 and I store this node number 2 here and I remove it from the call stack. Then I remove this DFS call for node number 1 as well and I store this node 1 here like this. Now if I look at this ordering from left to right, this is my topological ordering. Okay, this is my topological ordering which I require. Fine, and that's all. That's all about the implementation. We just have to perform the depth first search, and whenever I backtrack from any node, I just have to store the node in some data structure such that it comes the last. So node number 1 is stored in the last, and in the topological ordering it comes at the very first position. So which kind of data structure I must use while I'm storing these nodes, such that the node which I stored the last must be the node which I stored the first in that data structure must be retrieved in the last, while the node which I stored last must be retrieved first. So it is like last in, first out, or first in, last out. This is the kind of functionality our data structure must have, and that functionality is present in the stack. We know that. So all of these nodes must be stored in a stack, in an auxiliary stack, while implementing depth first search. So remember, this is just the call stack which is used to store the DFS function calls for corresponding nodes, but this is the auxiliary stack which will be used to store the nodes of the graph. Okay, so I initialize an auxiliary stack which I pass in the depth first search function, and while I backtrack from a given node while leaving this node, I have to store that node into that stack, so that when I have filled stack like this which contains the topological sorting, I can retrieve the elements from the stack in the order I require. So when I retrieve these elements, they will be retrieved like this: 1, 2, 3, 4, 5, 6. And this order is the topological order which I require. So after performing this algorithm, after storing up all the nodes in the depth in this in this auxiliary stack, all I have to do is to just declare another array. Let's say answer array, which will store the topological sorting, and just iterate over this empty iterate over this stack until this becomes empty, and just keep picking up the top node from the stack and pushing it into the answer, and that answer array will store the topological sorting for the given graph. So that's all I have to do in this problem. So let's list out the steps of the algorithm. So this is topological sorting algorithm using depth first search. The very first step is just to pick an unvisited node. So just use a loop, iterate over all the nodes using a for loop, starting from node number 0 till node number n minus 1 if they are numbered from 0. Now beginning with the selected node which is unvisited, just perform the depth first search exploring only the unvisited node. Okay, so from that unvisited node which I have selected, perform the depth first search, and on the recursive callback of the DFS, add the current node to the topological ordering in reverse order. So use a stack here, use a stack to store these nodes. So while leaving a node, while backtracking, just store the current node into the stack. So these are the 3 steps which you have to remember to perform the topological sorting, or to extract the topological order from the given directed acyclic graph. Okay. Now let's see the pseudocode implementation. So this is my top sort function which takes in the number of nodes, the graph itself. I simply declare a visited array which I do in the depth first search. Here I am declaring the auxiliary stack which will be used to store the topological sort in the reverse order. So here I am performing the very first step, that is iterating over all the nodes, and whenever I find an unvisited node, just start the depth first search from there. Okay, just pick the unvisited node, the very first unvisited node, starting from node number 0 till n minus 1, and just perform the depth first search where I have to pass in this node where I'm starting DFS, this visited array, the stack, and the graph itself. And here, after I have performed this DFS strategy, this stack will contain the topological sort in reverse order. And here I declare an array which will be used to store the top sort in the right order, and till the stack is not empty, just keep picking up the top node and keep storing it in the answer array, and that answer array will store the top sort in the right order. So let's see the working of this depth first search function, how we are storing the nodes in the graph while we backtrack from the current node. So this is a DFS function which takes in this node, the visited array, the stack, and the graph. I simply visit the current node, iterate over the neighbors, just check if the neighbor is unvisited. If it is unvisited, recursively call the function. So do this for all the neighbors, and eventually when we have visited all the nodes in the subtree of this current node, I come back to this node and I push this node into the stack. Okay, that's all I have to do, because Here at this point I have visited all the nodes, and I'm just moving to the parent node of the current node. I have already visited the current node and its subtree nodes, so I'm pushing this node into the stack. Now this stack I have to pass by address. Okay, I have to pass this stack and visited array by the references. So this is how the top sort algorithm is working. So let's see the code implementation of this algorithm. So I will be using C++ language here to implement the topological sorting. Okay, so let's create a class. Let's call it solution class, and let's create a function. Let's call it top sort function, which returns the vector. Let's call it topo sort, and it basically takes an adjacency. It basically takes the number of nodes and the adjacency list. In this top sort function, I will first declare a visited array. So let's declare a visited array of size n, and just and a stack. Let's call it st. Then iterate over all the nodes starting from node number 0 till node number n minus 1, and if we get some unvisited node, then simply call that function while passing in the current node, the stack, visited array, and the adjacency list. Okay, eventually I will have my stack containing the top sort in the reverse order. So for that, declare an array answer which will store the top sort in the right order. Iterate over the stack till it is not empty. Okay, just push the top element from the stack and just keep popping up the top element from the stack, and finally return that answer at the end of this function. Now let's see, let's implement this depth first search function. So let's implement this DFS function. So this DFS function basically takes in the current node, the stack. I'm passing in by address the visited array and the adjacency list. Okay, now let's visit this current node, iterate over its neighbor, iterate over the neighbor of the current node. So if this neighbor is not visited, then recursively call this DFS for this neighbor, pass in the stack, visited array, adjacency list, and that's all. And at the end, while we are backtracking from this node, while we have visited all the nodes in the subtree of the current node, then simply push this node into the stack. Push the current node into the stack. Okay, and that's all. This is the implementation of top sort algorithm in C++ language. I hope you got how we are doing this. Okay, so let's implement the solution in Java language. So let's create a class. Let's call it solution. Create a function which will return an integer array that will store the topological sorting of the given graph. So let's say topo sort. This will take the number of nodes and an array list So this is basically the graph itself, the adjacency list. I will create a boolean matrix. I will create a boolean array. Let's call it visited array. Let's call it visited array. We'll initialize this visited array with false. So visited is initialized with false. We'll fill it with false. Then we'll initialize a stack. Let's call it st stack. Now traverse over all the vertices starting from 0 till n. If I find some node to be unvisited, just call the DFS function right there. So pass in the adjacency list, send the node, the visited, the stack space, the stack itself. And declare an array. So declare an array A which will store the actual top sort in the right order. The stack contains this st stack contains the top sort in the reverse order. So initialize this I variable which will be used to point to the index of this array A. Now iterate over the stack till it is not empty and store the top element of the stack. Store the top element of the stack into the array. So keep picking up the top element and keep storing it in the array while popping out the element from the stock. So why now at the end return this answer array, this A array from the end of this function. So this is how this top sort function will work. Let's implement the depth first search function. So its return type is void. Let's call it, so it's DFS. It takes in the array list which is basically let's call it ATJ. Then it takes in the node, then it takes in the visited array, and that is basically visited, and finally it takes in the stack as well, stack of integer s. Okay, so let's implement this function. Now in the DFS I simply visit the current node. So this current node is visited, then it iterate over the neighbor. So if you find any unvisited neighbor, then recursively call this DFS function for that neighbor. Pass in the adjacency list, the current node, that would be atg.get. It's basically the current node. So I'm getting this current node here, and I will get node dot get I. Okay, so pass in the ith node, then pass the visited array and pass the stack. And after we end the DFS, after we backtrack, just push this current node into the stack. Fine. So in this fashion the DFS function is working. Okay, so that's all for this video. I hope you learned the concept of topological sorting and its implementation using depth first search strategy. So if you like the video, then hit the like button and make sure to subscribe to the YouTube channel and continue in this series. We will be learning one more implementation of this top sort algorithm, and after that we'll be solving a lot of problems involving top sort algorithm. So stay tuned with me. I hope to see you all in my next video.